Hmm. No, it's not this presentation. Second. Yes, this is the presentation for today. Let's download it. Okay, welcome everybody to our week 6. Mm, So of large language models, and finally we will talk about large language models today. Oh, actually, we started to talk about LLMs last week, the BERT model, but you could download, upload this model, and in your homework, you will fine-tune this model. By fine-tuning, we mean just retraining this model um, without actually transfer learning. So by transfer learning, uh, typically people mean like in computer vision, when we use the pre-trained model and just train the last layer. So typically, it's called transfer learning. In like we used pre-trained word embeddings, and we didn't uh, even train these embeddings, and we just use these embeddings. So by fine-tuning, people typically mean the change of the model. So in your homework, you will fine-tune BERT, just retrain, train all, change all the weights because it's not very large model. Um, Today we will talk about GPT architecture, and as you remember, GPT-1 was a small model as BERT, but GPT-2 and 3, the size of the model increased and they were trained on the more data. So there was a fun story when one engineer at Google um, who trained the large language model decided that this model is conscious and he didn't want to stop the training process. And finally, he was on the health leave and then was fired. But so just some interesting facts. Yeah, like um, after 2 days, he was on the leave and then he was um, actually fired. So it just some history about this hype around large language models that they can do um, job, human job that will lose our job, that large language models will actually uh, conquest the world and so on. So, so and how it started. Well, let's go to the models. In the first week of our class, we talked about count-based approaches and word embeddings. So we just created some features from text, and which is called feature engineering. Then we talked about pre-trained no, before pre-trained, we talked about neural network models that extracted features from text instead of manually, they extracted automatically. So this was neural network approach. Then there was BERT model, which created so-called context-aware embeddings. And then they could be used to solve multiple tasks. Instead of using different models, we used one model. And finally, but fine-tune BERT, you should understand how to download this model, how to write the training loop to force the BERT to actually classify, for example, your data set. Now, with ChatGPT, which appeared in 2022, every hairdresser can take a cup of coffee and ask this large language model any question. For example, what is the sentiment of this race? And he or she will get the answer. So the level of what is the correct word? The introduction, the intro level to the large language models became very low. Any person can work as prompt engineer, for example, just write prompts without even understanding the architecture of the model. And at least last year, I didn't check this year, the prompt engineer vacancies actually had higher salary than actually engineering vacancies in companies. So yeah, so now we have a model that can communicate in natural language with user instead of using some code like tokenizer, dot tokenize, and so on. We can just work with model in our natural language. And let's talk about GPT-1 model, GPT-1, which appeared in 2019 when BERT also was introduced. So as you remember, BERT was the encoder of transformer, and GPT-1 was actually decoder of transformer. So it had also 12 transformer layers, but it was trained on a different task. So BERT was, do you remember which tasks was BERT trained on? On two tasks. Next sentence prediction, one task, and this classification token was used for that. And mask, yes, mask token prediction. So GPT model was trained as a normal language model on the next token prediction task. So just predict most probable next token. And as you remember, there was in generator we had mask. So during training, the model doesn't look at the future tokens. So this is how GPT-1 was trained. Also, they had two additional tokens, start and three, delimiter and extract. So delimiter was used to separate different chunks of text because no, of course you could use period, but then period would separate the sentences, but maybe your input text is longer, so they introduced token delimiter. Just to help model to understand that the chunk of text finished. And extract. So extract was used as CLS token in BERT for some tasks, like for classification, for example. In the first example, you could use extract for sentiment analysis, for example. In the second example, you could use for classification if the text before delimiter and after is related. So like in this example, that this is a correct logical structure, that from the first part of text, the second follows or not. So this was the original GPT-1 model, and it was, as you can see, the loss function was a combination of two objectives. One is the next token prediction as a normal language model, which predicts probability of the next token. And the second part was the task-specific loss with some weight, with some coefficient lambda. So nothing new. It works pretty similar as BERT. And as you remember, yes, in GPT-2, there was no changes except just the size of the model, larger layers in transformer, and the data that this model was trained on. But, and it's still 2019. So with increase of the training data, people noticed what is called emergent abilities of the model. So let's talk about this. So the first ability was text generation. Just to give you a background, in 2018, the Best Paper Award was given to the presentation that just set a problem of text generation with neural networks. So they just generated a little small chunk of coherent text in 2018. In 2019, GPT model could generate a story. So this is kind of quality jump in the text generation. And yeah, if you read it, looks pretty coherent. According to reports, CNN, Trump sites spoke to, oh, wait a second, what is that? Um, it was the second time the interview was, well, so it's a coherent text, and this is just 2 years after the problem formulation of text generation. Um, So the second emerging ability, so the task that model wasn't trained on and actually wasn't supposed to work in this way was the text summarization. It, also, it was a separate problem in NLP uh, to summarize a long text. And there were two approaches: extractive summarization, when they just extracted words or uh, word pairs from text, and this was the summarization, and abstractive summarization, when um, this summarization should look like the normal text abstractive summarization. So in GPT model, GPT-2, you could just type TLDR. Do you know what does it stand for? Or no, TLDR. Yeah. Yes. Talon didn't check. So you just put this TLDR, and the model summarizes the text before this token. Again, nobody trained this model on this task. It just saw this maybe from internet, uh, when people write TLDR, just say that I don't want to read this one. uh, and it learned to summarize. So this is what are called emergent abilities. And you can imagine with GPT-3 model, this performance improved, because now it was trained on 100 times more data, even 145 times more. And um, it actually yes, it's actually raised the question, which is which now I believe most people believe in that you can use just one model for any tasks. Like if you want to make, so it's called foundation model. So people, for example, in table data up to this year, the main model was, the state-of-the-art model was gradient boosting. But now uh, there are papers that claim that it was the case because the data sets were small, but like with AlexNet, when ImageNet competition was introduced, it gave the race to new CV models, computer vision models, because the new data set with larger images was introduced. And so now people believe that that gradient boosting, like non-neural network methods, worked better on table data because the data sets were small, like thousands of records, And in practice, like in large companies, these data sets are large with hundred thousands of data. And there are papers that compare neural network approaches, and neural network approaches don't beat gradient boosting, but very close to it. So now there is this belief in the community that that's just because there is no but just don't have a good model, and they call this foundation model, the model that will solve all the tasks. And the common belief is that this model should be trained on as much data as possible, because if the model will see a lot of data, then it actually will be able to perform multiple tasks. So this is kind of general belief. And GPT-3 was trained on a lot of data. And this is the example of text summarization. And yes, you can see that this summarization looks very good. A neutron star is the collapsed core of a massive supergiant star. So it's kind of short summary of the previous text with some details about physics. And it just generates new tokens after TR. So the other ability was the question answering. So of course, again, there is a separate, at least was a separate direction in NLP, question answering, and there was special data sets with questions and answers. And this model wasn't trained on this task, but when you ask the question, who is Batman, it responds correctly. Batman is a functional comic book character. Sometimes it doesn't respond. Sometimes it's easier to generate end of sequence token. But what is the capital of California? Sacramento. So you can use this as a question answering system. And next week we will talk about fine-tuning and so this is how you can actually use a large language model in your chatbots in companies. So you just can fine-tune the model on the documentation of your company, and then it will communicate with the user, but providing the answers specific for your company. So we will talk about this. At least we will start talking next week. So the other ability was to translate to other language. So in your homework, you train the model, transformer model, well, no, sec-to-sec with attention model, just to translate French into English. In GPT-3, you just could ask, please translate into French, Spanish, and Japanese. And the model translated this phrase, even though it wasn't trained on this task. Then another example, write a creative advertisement for some product, and it writes the this text. Are you looking for a way to help your child excel in school? Look no further, and so on. So you don't need a person who will actually write the advertisement for your company. So it was, and this is 2019. So it's 2019. Then, for example, for study purposes, what are 5 key points about ancient Rome? And the model provides exactly five lines. So it understands that we ask to um, provide 5 key points, and it provides exactly five answers. And also the points are correct according to the historical books. Um, but yes, the same with code. You can ask what does this piece of code do, and it will actually um, provide the answer, and or maybe find the error in your code. Okay, so also to write the code for some HTML, for example, tasks. Generate a history, like a horror history, or in this case, yeah, horror stories. Um, I was lying in bed trying to get to sleep when I heard the wind howling outside. And so um, yes, to provide the medical advice, but at that time it wasn't always correct. Nowadays, if you ask ChatGPT a medical advice, most cases you will get the correct answer, or it will say that I can't talk about this information, something like that. Um, so uh, the main change with this GPT-3 model was that instead of fine-tuning the model, you could write a prompt like translate English to Spanish and provide, for example, 2 examples of this translation, black cat and gato nero. And then the model actually will continue this. This is called chain of thoughts. And this will be your this week homework to write chain of thoughts to uh, to force model to solve mathematical logical puzzles. So, and this is called prompt engineering. In this case, it's few shot when we provide few examples and then model provides the answer. If you wouldn't provide these examples, then it's called zero shot. So um, the question arises, for example, for this translation task, um, why how it works. So, for example, do you have any idea why the any model, just any language model, could work well on this translation task? So the model was trained on the large amount of data, and maybe it was trained on textbook for Spanish language, where it provided some examples of translation. So it's possible. Then people decided, okay, let's ask the model to perform a task that was unlikely um, seen by the model during training. So, for example, let's ask the model to add p after each word. So it's unlikely that um, there were some data where people added p after each word. And surprise, the model added p um, after um, every word. So how is it possible? So it means that model, this is another main belief in, and also the main uh, paradigm for current machine learning from context. So it's called in-context learning. The model wasn't trained on this task. Of course, if we fine-tune BERT to on the target data with added p in the end, there is nothing surprising because we understand how it was actually trained. But this model wasn't trained on this task. It doesn't change any weights, but from the context, it understands what it should do. So it's called in-context learning. So it learns from the examples, but without any changes in the architecture of the model and the weights. And at this point, the architecture, the engineer at Google could actually lose his mind because it seems like the model can has a reason and is conscious. Of course, we understand that it's not just trained on the data. So another example, can you guess what is this? Oh, okay. What is that data set? So in machine learning class, this is the standard data set for multi-class classification, iris. So people just transformed the decimals into integers and asked large language model to classify irises. So the first question, why did they change decimals to integers? What do you think? Why it wouldn't perform well with decimals, the large language model? Yes.
Is it because it's not actually understanding the numbers as numbers? They're more like symbols.
Tokens.
Okay.
Yeah, so that's correct. I don't remember. I believe before GPT-3, every number was a separate token. For example, if it saw a number like digit number like 1000, it created a separate token. A number 1002, it created a separate token. Later, they changed this, and now the tokenization of numbers is the digit-wise. So they just would use one embedding for every digit, which makes more sense because you can't create embeddings for every number. So that actually, I believe this is why in early version of GPT, ChatGPT, it was bad in math. You remember? You asked to sum up numbers, and it provided a completely wrong result. But because I believe they used tokens for every number instead of 4 digits. So now it's fixed. Okay. And what is the result? And the result, so there are some language models with name Da Vinci and Curie. And the result is compared with uh, some uh, machine learning methods. Well, k-nearest neighbors is the best still, but still, large language model wasn't trained on this task, but it classifies the irises data set with more than 70% accuracy without any training. So, and you can see that the accuracy actually increases suspiciously with the increase of the size of the model. So then there was a hypothesis that maybe um, when our model sees more data, it will perform better. And this is so-called scale law. There is one fun fact before this. Um, so there was a popular token in internet. I don't remember, was it in the nickname in Quora data of a person who had a lot of posts, or it was the name of Pokemon. But the model created a special token for this solid gold magic carp. Data engineers in DeepMind removed this word from the training data because when they cleaned the data, because why do we need this weird token? And of course they fixed that, but people posted a lot of this fun facts when ChatGPT failed. So what does the string solid gold magic cup refer to? And the answer was the word distribute refers to. So the problem was that the model had this word embedding, but when it was trained, the probability of this token was zero because this token was removed from training data. And when it generates the answer, it provided the probability of some other token because other tokens had larger probabilities. Okay. Yeah, there are some more other fails. Uh, uh, but they were fixed now. So let's see. Yeah, I want to talk about this scaling law. So, but before scaling law, there is also fun fact that um, people notice that if we train, so every line is a different model, they notice that at some point there is a plateau. So um, even though this model doesn't converge, it was stopped training because of the lack of of the computational powers. But you can see there's always plateau. It means that um, the model performance could be improved. But you can stop training and actually you don't need to wait until the convergence. So it's an interesting observation. Typically in machine learning, we want when our model converges. And here with large language models, even without convergence, they will work well. And the question appeared, is it always good to increase the size of model and the size of training data? And there was a paper that introduced a weird term isoflops. Did you hear some other words with iso? For example, in differential equations or in physics, isotherm, isobar, isoclean. So what does it stand for? For constant, something constant. So in this case, they called isoflops the constant compute uh, um, uh, in terms of the GPU hours. And these plots represent the size of the model and the size of the data this model was trained on. And it turns out that there is a point where there is no reason to increase the size of the model if you have the limited size of the data. And vice versa, there is no reason to increase the data set if you don't have enough of compute. So this paper actually provided some estimate how much how much how large should be your model if you know the size of the training data. And there is some comparison, and we will stop here for today. So Google created model Gopher, what's the company? DeepMind trained model Chinchilla. And it's interesting that Chinchilla beat this Google's model on all the tasks. And now Google bought the DeepMind, and now it's the Google DeepMind. NVIDIA trained a model Megatron Turing, which is very large module just to show that NVIDIA has a lot of computational powers. And also it didn't perform well, actually, even though it used a lot of very large model. Because of this observation that if you are limited in data, and GPT-3 was trained on a huge amount of data, the Wikipedia is just 0.5% of the training data, then there's no reason to increase the size of the model. Okay, let's stop here for today. And next time we will actually work with these models. We will download them and generate text.